In this next video, we're going to look at how to determine the speed or velocity of an object in free fall motion. Before we do that, let's talk about how to relate the difference quotient and average rate of change to give us speed. So the difference quotient by itself, which is f of x plus h minus f of x all divided by h, gives us average speed. Now the instantaneous rate of change, or the instantaneous speed, is given by the limit as h approaches 0 of the difference quotient. So again, the average speed is given by the difference quotient, and instantaneous speed is when you let h approach 0. So in example 6, we're going to recall the rock falling problem from when it's falling from rest, and it's given by the equation y equals 16t squared. This is how we do the average free fall motion in foot per second on Earth. So we're going to find the speed of a falling rock when t is equal to 1 second. So to find instantaneous speed, we take the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so since f of x is equal to 16x squared, we get that f of x plus h is going to be 16x plus h squared minus 16x squared all divided by h. And now it comes down to just doing some algebra. And so we get that the equation to find instantaneous speed at any time is 32x. Now keep in mind that we were using time, so I'm going to rewrite this as 32t because we're using time and not x values. So the next step is to let t equal 1 because we want to know the speed at 1 second. And so we get that this is equal to 32 times 1, which is 32 feet per second. If I wanted to know, say, at t equals 2, I would just plug in 2. So you would get 32 times 2 is 64 feet per second, and so on. If you want to know other times, you just follow the pattern. Now, because this is a word problem, they asked us the question in a sentence. We're going to respond in a sentence. At t equals 1 second, the rock was falling at 32 feet per second. And now on your own, I want you to try to find the free fall of an object on Mars. So the free fall motion on Mars is y equals 1.8 d6 t squared. And we know a rock is dropped 200 meters. And I want you to find the rock's speed when t equals 1. Again, you're going to use the same process as before, but go ahead and give that a try. Alright, let's work it out. And we know that instantaneous speed is given by the limit as h approaches 0. And again, I'm going to use t instead of x because our variable's in t. So we know we have our function up here, which is f of t is equal to 1.86 t squared. So then f of t plus h is equal to 1.86 t plus h squared. so we get that the velocity or speed function is 3.72 t. And so now we're going to use our t value of t equals 1. So we get that this is 3.72 times 1, which is 3.72 meters per second. And you do get a point on the test just for getting the units correct. So now our question was in a word sentence form, so we're going to answer in a sentence form. So the speed of the rock at t equals 1 second is 3.72 meters per second.